Hello everyone. In this video we're going to be solving an interesting quartic equation. It's actually a pretty interesting one because we're missing a lot of terms and the solution methods I'll be presenting will be more than two. So at least three probably. So let's go ahead and see how we can approach this problem from different angles. And for the first one, I'm going to be using, actually this is meant to be the second, so we're going to start with the second method. The second method basically uses a pretty typical approach. So let's go ahead and put everything on the same side by subtracting 1 from both sides. So we can set it equal to 0. And then try to factor the left-hand side. How do you think you're going to be able to factor the left-hand side, right? It's a quartic, but missing a lot of terms. So we can probably safely say that, well, this is going to be like this, x squared, and then followed by ax, and then maybe 1, right? One of the factors. And the other factor, we have an x cubed term, so you got to be very careful. You can't use x squared minus ax because that'll cancel out the only x cubed. So we kind of have to write it like this, x squared plus bx, and then plus 1, and then that's going to turn into minus 1. And it doesn't matter which one is which because a and b are interchangeable, so it wouldn't matter in this case, right? Now I could also use a coefficient for x squared and x squared here, but again that wouldn't matter because they're both 1 or both negative 1, in which case we could also turn them into both 1. Make sense? I hope it does. Now let's go ahead and see how we can solve the problem from here. So I'm going to go ahead and distribute everything. We're going to get x to the fourth, and then plus bx cubed minus x squared. And then next we're going to distribute this, plus ax cubed plus abx squared minus ax. And then we're going to distribute the 1, plus x squared, and then plus bx minus 1. Great. This is supposed to equal this. So now we can see that x to the fourth agrees, but we kind of need to put together these terms, right? X cubed, so let's go ahead and write it this way. X to the fourth plus b plus a x cubed. X squared is going to cancel out, leaving us with the only x squared, which is ab, x squared, right? And then we're going to get plus b minus a as the coefficient of x, these two, and finally minus 1. And then these two are supposed to equal each other, which means b plus a is negative 4, right? B plus a is negative 4. And then ab is 0, which is weird, right? Because we don't have any x squared. And then ab is supposed to be 0. And then b minus a is also supposed to be 0, which means b equals a. But that's not the case because if a and b are both equal, then they should both be negative 2. But negative 2 and negative 2 does not satisfy this equation. So here's one thing we assumed, right? We assumed that the coefficient of x squared needs to be 1 and 1 or negative 1 and negative 1. But that doesn't have to happen. Why? Let me tell you why. You can have different coefficients here, like let's say c and d, such that their product is 1, but they don't have to be 1, 1, and negative 1, negative 1. Make sense? Okay, so this method shows you our factoring is not going to proceed from here. So let's go ahead and clean this up. And then what we're going to do is try a different approach. So we kind of need to be more generic in terms of factoring this. So here's what we're going to do. This is just to show you that this method is not going to work like that, okay? Now, here's what we need to do. We need to write this as ax squared plus bx, and then we can follow up with 1. That shouldn't be a problem because by the way, the constant term doesn't have to be that way either, right? So you could probably say something like, okay, maybe this is going to be a c and that's going to be a something else, but you can also try it this way. So let's go ahead and take a chance here and then write it this way. And of course, we do need dx for follow-up minus 1. Okay, let's see if this is going to work. Now, after distributing, you should be getting something like this. To keep a long story short, you're going to get ac x to the fourth plus ad plus bc times x cubed plus c minus a plus bd multiplied by x squared, and then d minus b as the coefficient of x, and then minus 1. Now you want to compare this to x to the fourth minus 4x cubed minus 1, which means this is equal to 1. Like we said earlier, a and c don't have to be 1, 1, and negative 1, negative 1. And this needs to be negative 4. This needs to be 0. This needs to be 0. And negative 1 matches up with negative 1. Okay? So far, so good. Now, this gives us a system like this. Because d and b are equal, AC is equal to 1, right? AC is equal to 1. And then what else do we have? AD plus BC is equal to negative 4. And then C minus A plus BD is equal to 0. And D is equal to B. So one thing you can do is you can definitely replace D with B everywhere. So from here it will be D with B, AB plus BC is negative 4. That's going to simplify things a little bit. And here you can replace the D with that. So that'll give you plus B squared. But you can also isolate B squared and write it as A minus C. Okay? And along with the first equation, you now have 3 variables. So solving the system should be easier. Again, thinking about A and C, right? If A and C are both 1, 1 or negative 1, negative 1, we know it's not going to work. So there's no way we're going to try it again, right? So we know that they're different because it didn't work. But let's just try to solve this system. Like, how could you possibly solve it, right? Maybe from here, I can isolate C, write it as 1 over A, and then use it in the second and the third equation. So from here, we get AB plus BC, which is 1 over A, equals negative 4. That kind of gives you AB plus B over A equals negative 4. And if you make a common denominator, you get A squared B plus B equals negative 4A. In other words, multiply both sides by A, right? Great. That's one of the equations that we're going to use, hopefully. And here, if you do the replacement, you get B squared equals A minus 1 over A. That's just another equation. Now, notice that we have 2 unknowns and 2 equations, so we should be able to solve it, right? So how can we solve it? Well, first of all, notice that from the second equation here, this one, B squared is isolated. So let's go ahead and work with B. From this equation, if you factor out the B, you get A squared plus 1 equals negative 4A. And from here, you can write the B as negative 4A divided by A squared plus 1. So this gives us a nicer formula that we could probably use here, right? B is negative 4A over A squared plus 1. So replace B with that. Of course, you have to square it. And then set it equal to A minus 1 over A. Notice that the only variable is A. So we should be able to solve for it, right? Let's go ahead and give it a try. It's not going to be that easy. You're going to get 16A squared divided by A squared plus 1, quantity squared. And this is A squared minus 1 over A. Okay? Now, we're going to do some cross multiplications. And one thing that might make it a little easier, this is going to give us 16A cubed. And this one is going to give us A squared minus 1 multiplied by this, which is A to the 4th plus 2A squared plus 1. If you distribute, you're going to get 16A cubed equals A to the 6th, a hexic equation, not too good, plus 2A to the 4th plus A squared minus A to the 4th minus 2A squared minus 1. Awesome. Anything cancels out? Nope. But these two are like terms, and these two are like terms. So we're going to get something like this, A to the 6th plus A to the 4th. And then bring this over, minus 16A cubed. So we've taken care of this, 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 and now this is going to give us minus A squared minus 1 equals 0. Now, this is a hexic equation, so it's pretty hectic. Can we try to solve this equation for A, right? That would probably be super duper hard, but maybe I made a mistake and we got stuck here, but that's basically what I got. Hopefully this is correct, and we could probably check with a calculator. But let's go ahead and proceed with the first method, okay? Because I think the first method is probably my favorite, but again, you're gonna decide. So we have the following equation: x to the fourth minus 4x cubed minus 1 equals 0. So actually, the first method is going to use a totally different approach. So we're going to make this into something else. First step, we're going to split the x to the fourth into 2x to the fourth minus x to the fourth, okay? And then we're going to keep the 4x cubed, okay? And then we're going to go ahead and add 2x squared and subtract 2x squared, and I'll explain why we do that, okay? So far we have 2x to the fourth minus x to the fourth, which works. We have the minus 4x cubed, which is there. 2x squared minus 2x squared is going to work, and all we have left is minus 1 equals 0. So notice that these two expressions are the same. But why did we write it that way, right? We're going to put this one, and this one together. Let me show you how that works. 2x to the fourth minus 4x cubed plus 2x squared. And then the rest will be minus x to the fourth minus 2x squared minus 1 equals 0. So the idea is to be able to write this as a difference of two squares. And that's not going to be very easy, right? How on earth would you discover something like this? By trial and error, maybe. But here, if you factor out a 2x squared, you're going to get x squared minus 2x plus 1 minus x to the fourth. Everything will be negated inside the parentheses, right? It's going to look like this. Now, this is 2x squared multiplied by x minus 1 quantity squared. And this is x squared plus 1 squared equals 0. Now, you can approach this in two ways. Either as a difference of two squares, or you can isolate this part, the right-hand side, put it on the right-hand side, and then proceed with the square roots, which will bring absolute value into the equation, so on and so forth. No big deal. This is what I'm talking about. If a squared minus b squared is 0, you can either factor it like a plus b and a minus b, and then solve from there, or you can just write it like this first, and then proceed with a plus b, a equals b, and a equals negative b. Again, this is from the absolute value. Make sense? Same thing. But let's just go ahead and use the first one because it uses factoring. So, and by the way, if this is your a squared, you have to square root it, right? But let's just go with the positive square root. It's going to be root 2x multiplied by x minus 1 plus, this is my a, by the way, this is a squared, this is a, plus b, which is x squared plus 1, okay? And then this will be multiplied by, and I'll probably just move this out of the way so we can have more room. Oops. And this a should be here, okay? So supposed to go to 10. Okay, and then the other factor is just going to be square root of 2x times x minus 1, which is a again, minus b. But be careful because b has to be in parentheses, okay? This should be easy, fairly. Now take a look. Notice that this is a quadratic equation. If you distribute, you're going to get root 2x squared. Along with the 1, it's going to be like that. Minus root 2x plus 1. Again, the other factor is going to be similar, but root 2 minus 1 x squared. And then minus root 2x. And then finally, you have the minus 1. Okay, equals 0. And notice that we got two quadratic equations that can be solved. Let's just do one of them because they're very similar. X is equal to negative b. Notice that b is the coefficient of x, so we negate it. Plus minus the square root of b squared, which is 2, minus 4 times a times c. Okay, and then divided by 2a, which is 2 times square root of 2 plus 1. This should be the answer. The problem is the delta is going to be negative. Why? Because if you look inside the radical, you're going to get something like this. The delta here is going to be 2 minus 4 root 2 minus 4, which is negative 2 minus 4 root 2. And that's definitely less than 0, which means you're not going to get real solutions. By the way, this channel mainly deals with real numbers because I have another channel that is dedicated to complex numbers, which is called aplusbi. Make sure to check it out. Okay, now you can go ahead and finish up in terms of complex numbers and try the other one. Do you think this is going to have complex roots too? Okay, let me not tell you what the answer is. And now we're going to proceed We did the second method and the first method, right? And now we're gonna do the third method, which I wasn't really thinking about presenting, but then I thought about it like, okay, this makes sense. Okay, this is the original problem, right? So here's what I wanna do. I wanna add something to both sides to make a perfect square on the left-hand side, okay? And what would that be? If you are familiar with these kinds of expressions, you'll soon realize, okay, if I add 4x squared, right, it'll be a perfect square. Why? Because this will be x squared minus 2x quantity squared. If you don't see that, there's an alternative. You can factor out x squared and write the rest as x squared minus 4x plus 4. And hopefully you're going to realize, we have a perfect square inside the parentheses. It's x squared multiplied by x minus 2 squared. Now you can combine these two things and just write it as the square of a product. In other words, like this, right? Same idea. And of course, the right-hand side, let me just write the 4x squared first, is not a perfect square, unfortunately, right? But that's not a problem. Houston, we have a solution for that. And here's how it proceeds. And I want to thank Nadia Fan for this method because that's how I learned about it. I think it's called Descartes or something like that. Anyways, doesn't matter the name of the method. But you take this expression to this, you add something like this, 2k multiplied by x squared minus 2x, and then of course you add the k squared. So this is what you're adding, and I'll tell you why we're adding it. And of course you have to do the same thing on the right-hand side, right? So we have this plus this. Make sense? Hopefully it does. Now here's what I'm talking about. When you have a squared and you want to turn it into a perfect square, in this case, this happens to be a, you add 2ka plus k squared. Easy, right? Okay, great. Now, what do you do with the rest? Let's see. So we should have something like this. I think this is going to work, right? I hope so. So here's what we get after adding. X squared minus 2x squared plus 2k times x squared minus 2x plus k squared equals 4x squared plus 1 plus 2k times x squared minus 2x plus k squared. Now the left-hand side, if you call this a, this is a plus k squared. In other words, x squared minus 2x plus k quantity squared is going to give you the left-hand side, right? And the right-hand side is, wait, that's not right, is it? A plus k squared, yeah, that's correct. It looked weird to me for a second. And on the right-hand side, we can actually put together the k squared terms, like this is 2k plus 4x squared, right? And then we have the minus 4kx, and then plus 1 plus k squared. Plus 1 plus k squared. Okay, great. Now, we know that the left-hand side is a perfect square. The right-hand side also needs to be a perfect square. I mean, hopefully, right? And in order for that to happen, we need a zero discriminant, delta, the same idea, right? So what is the delta for this quadratic? It is b squared minus 4ac. Easy, right? Okay, this is supposed to equal 0. And from here, guess what? You're going to get a cubic equation. Good luck with that, because this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath and aplusbi. And bye-bye.